Hello friends, thank you for watching this video. I am Mohamad and today we'll be going through some of the C# 9 language highlight. So what are we going to be covering today? First we're going to be discussing target type new expression, and then we're going to be going through property pattern matching, tulip pattern matching, init-only setters, default interface methods, as well as we're going to be discussing the ingredients that we're going to be needing in order for us to explore all of these features. As always, you'll find the source code in the description down below. Please like, share, and subscribe if you like this video. It will really help the channel. So, what are the ingredients that we need? We need Visual Studio Code as our text editor, and we need .NET 5, our .NET SDK. Links for these two will be available on the screen and in the description down below. So let's get started. So the first thing we're going to be doing is we're going to be checking the .NET version SDK. In order for us to do that, we're going to type .NET -- version, and here we should see the latest version of our .NET SDK installed. Perfect. The next step is we're going to be creating our console application where we're going to be exploring all of the features in it. So in order for us to do that, we're going to put .NET new console. We're going to give it a name. We're going to call it CSharp highlights. We'll give it CSharp highlights, and let's wait a few seconds for it to install. Perfect. Now the application has installed successfully. Let us navigate to the folder and let's open it in Visual Studio Code. Great. Now that we have opened our application in Visual Studio Code, the first thing we're going to be doing is we're going to be opening our terminal, and we're just going to build the application to make sure everything is building successfully. Great. And then we're going to run it. Just should see a hello world after this. Perfect. So now the application is building and running successfully. We can start. So the first thing that we're going to be exploring is target type new expression. So first let's open our program.cs and let's create a new record. A record is one of the new features that C# 9 has introduced. So how do we create a record? It's very simple. We just put record, and we're going to give this record a name car, and this record's only going to take a string of brand and another string of color. Great. So now that we have our record ready, the next step for us is we're going to be creating some record data. So inside our main class, after the hello world, let's first create car. We'll call it car1 equal new car. We're gonna just give it Toyota, and we're gonna make it black, for example. Now let's copy this and we create two other instances. Car2, car3, and this is gonna be a Honda. This should be white, and this should be a, for example, Nissan, and this should be red. Okay, great. So what is targeted type expression? Targeted type expression means that we're going to be able to express ourselves and express the code that we want with way less code. So for example, typically if we want to create instance of a record or of an object, we have to do it this way. So we have created car1 equal new car, and then we have initialized it. But then after that there was some changes. So what was the changes? So I think within C# 7, so instead of putting the object directly here, we did this. We have switched car and we put var, and so right now var will automatically inherit the value or the type of the class, and will for the new object that has been initiated. So it's automatically implemented to it once we initiate this object. So this was the new expression. So we didn't really have to do the initialization of the object here. So we didn't really have to say car equal new car, etc. We should have said var, and var the type was automatically implemented from the object that we're trying to initiate. So But what happened with C# 9, we took this step a bit further, and instead of having it like this, instead of having the var here, we're able to remove the initialization from the new, and we can directly initialize it. So we can see here that we have defined the variable and we gave it the type that we want, and then we directly initialize it. So right now, because we did it like this, C# will automatically know that this new object that we're trying to initialize will take the same value of the class here. So this is why this is a bit shorter for us and the new way of initializing object. Don't get me wrong, all of these are still valid, but this is gonna save us a lot of time when, for example, trying to create or initiate a lot of objects. So let's see this in action. Let's say we have a list of cars. So let's say we have an array of cars, so car, and we're gonna call it cars equal, and this, for example, gonna be something like this. New car, and let's just take the random information, for example, and we'll just put car 1, for example, and put white. Okay, so let's copy these, and let's say we have an array of all of these, so of 6 cars, and this is gonna be 2, 3, 4, 5, and 6, and all of these 6 cars are white. So right now, as you can see here, we have the first here, we define the array of type car, but then every time we are declaring the object, we are just repeating the same word, which is car, car, car. So how can we make this easier? So with this feature that has just been introduced, we don't really need to define it that it's a car type, because it will automatically take that object type from the main object here. So since it's an array of cars, we automatically have new objects of car. So this is like a small enhancement, but it will allow us as well to write a bit less code and make our code more readable and much more compact. And as well, you can see that the code is a bit neater and it's still doing what I was expecting it to do, which is basically creating an array. So now let's try to loop through it and see if it's actually gonna be giving us the same output. So for that, we're gonna just having a for loop. So we're gonna have a for each, and then we're gonna put for C, for example, in cars, and basically we're just gonna put console.writeLine, and this console will get the write line. All it's gonna do is just gonna be displaying the list of cars for us. So let's use string interpolation, and we're gonna put the car name, for example. We're gonna give it c.name, c.brand. Yes, and then we're gonna give it the color. Has a color of c.color. Great. And instead of name here, let's put a brand to make it more consistent. And let us now build the application. So .NET build. Great. Now let's run the application. .NET run, and now we should see an iteration of this list. Perfect. So now we can see here that the car brand car 1 has a color white. Let's change a bit of the information so we see that. So this is gonna be black, for example. This is gonna be red, yellow. For example, here we can put orange, and here we can put green, for example. Okay, let's try this again. Perfect. We can see the different colors, and we have different car numbers. So the new syntax changes that we did not really affect the functionality. All it did is make our code neater and smaller and much more easier to read and maintain. Perfect. So the next point that we're going to be discussing today is property pattern matching. So in the example right now, what are we going to be doing is we're going to still utilize this car records that we have, but we're going to be creating a new method. The method that we're going to be introducing basically is going to be calculating the tax of the car. And in order for us to do that, let's create this method together and we can explain how it works. So this method is going to basically return a decimal, and we're going to call it calculate tax. And it's going to take the car record that we have created. Okay. So we're going to utilizing the arrow function. And within this arrow function, we're going to be looping through cars. So basically we have a switch expression, and this switch expression is going to be based on car. So here we can see car, and we're going to utilize it's a switch. And then basically from here is we're going to be looping through the brand of the car, because as we can see, car is a record, and the record has two values, which is the brand and color. So right now the switch expression is going to be working on the brand. So how do we do that? We just put this and brand, and then we defined if it's, for example, a Toyota, for example, we're gonna calculate the sales price. So sales price, for example, multiply by 0.02, and now so on and so forth. So for example, the other brand, if it's gonna be Nissan as well, sales price multiply 0.021, for example. And let's just copy this. And okay, so we said we have Nissan. So Nissan, we have, for example, Honda, Toyota. No, we said Toyota. We can have BMW, and we can have a Jeep. So the Jeep, because it's a 4x4, we give it a higher tax. BMW, give it a 3. A Honda, we'll give it a 19. Okay, great. So now that we have this, the last thing we need to do is we're gonna introduce the default value. If there is no matching at all, we're just gonna return a 0. And this is it. So basically what we did here is, within this switch expression, this is a switch expression on the brand itself. So we're evaluating the car instance of each of the case arms. We are evaluating the individual properties to calculate the tax. So let us use this in action. Let's change the car brand so they will match this. So for here, for instead of car 1, we'll put Toyota. Another one we'll put Nissan. Another we'll put Honda. And then we have, for example, BMW and Jeep. BMW, Jeep, and a Mercedes. Great. So now let us calculate these tasks. So how do we do that? So now let's try it up. So we're gonna be creating the tax. So we're gonna put var tax equal calculate tax, and we're gonna be passing the let's say we're gonna pass the Nissan, which is gonna be the second item. So we're gonna put cars, and then we're gonna give it a sales price, for example, of 8,000. Great. Now all we're gonna be doing is we're gonna be displaying the output of the tax. So console.writeLine, and we're gonna use string interpolation again, and we're gonna say the tax is, we're gonna put tax here for specify the car, which is gonna be cars 1.brand. Okay, great. Let us build this application and see what we get. So .NET build. Perfect. Now let's run it. And as you can see here at the end, that the tax for the car is gonna be £168, for example. And we can see here that we utilize the switch statement in order for us to do the calculation based on the car brand. So in summary, we are passing an instance of the car, and this feature allowing us to inspect all of those properties of those cars, and basically in our case it's going to be the brand, and based on that, the value of the brand, we are getting the tax. Now let's say that we want to match on more than one property. So currently we're utilizing the brand, but for example we wanna match on the brand and the color. So we can achieve this by utilizing the compound property expression, where the order does matter in order for us to utilize it, and basically the order takes precedence. So let's say we want to add colors right now here in order for us to do more, for example, of this calculation. So let's say we have one Nissan which is black, and let's say another Nissan which is white, for example. And for any reason, for example, the black Nissan is gonna have more of a tax rate than the white one. So how do we do that? It's very simple. So as we said, the order is a very important thing, and it takes precedence. So first let's take this, let's copy it and put it on top of it, because this is where we're gonna be adding the extra condition. And then here what we need to do is we can put a comma, and then we can specify the color, and for this color we're gonna say black. Is it capital B? Yes, capital B. And we're gonna say if it's a black color, we're gonna have a .3, for example, tax. And we're gonna be basically, instead of passing Nissan, so this is gonna be the third one, we're just gonna do the same thing for the third. So far, black Nissan tax equal calculate tax, and we're gonna pass cars, I think it's a yes, the third, and we're gonna give it a sales price of 9,000 for it. Let's give it the same price of 8,000, and we can see the difference. And then all we need to do is just copy this, and we can see the different outcomes. So this is gonna be the black Nissan tax, and here's gonna be 2 for the second one. And let's add the color so we can actually set the color. And here we can have, for example, cars 1 dot color, and here we can have cars 2 dot color. Great. Now let's build this. So .NET build. Great. Now let's run it. .NET run. And as you can see here, first let us remove those for each that we don't really want anymore. So let's comment them out. And let's run it again so we can have a much more cleaner. Let's clear it. And we can put .NET run. And as you see here, for example, for the black Nissan, we have a much more higher cost than the white Nissan, because basically what we said here is inside our switch statement, if the brand and the color match what we have. So for example, here we are matching Nissan and the color black, we are giving it a sales tax of 0.03 instead of the normal Nissan where we're giving it a sales tax of 0.02. So for this reason here, we have two different answers. So although they are the same Nissan, but because they have different color, the tax calculation is going to be different. So this is how we do multiple properties using compound property expression in order to do us within a switch statement. So the next feature that we're going to be discussing is init-only setters. This new feature in C# 9 is one of the features that will allow us to add immutability to our code. So let's say that we have a class of employees. Let's now create a new class of employees. So class and employee. And this class basically is going to have three properties. Let's delete this. Okay. So the first property is going to be first name, so of type string. And let's copy this. So last name and email. So this is going to be last name. And this is going to be email, for example. So now let's say that we have within this class property or type that we don't want to change the property after it has been initialized. So how can we do that? So for example, here now we have the employee class, and let's say after we initialize the first employee, we don't want really anyone to be able to modify that object that we have created. So prior to C# 9, there was multiple steps of how we can do that. So let's go through them and see how C# 9 changed those. So the first thing, let us create a new employee, initiate a new employee. So we say var emp equal new employee, for example. And basically we're just going to give it first name. It's equal to my name, so it's gonna be Mohamad. Last name, it's gonna be Lawand. And for example, email, it's gonna be Mohamad at, let's say, email.com. Great, and let's stop this here, put a semicolon. So right now, after we have initialized this, if for example I want to update my email, all I need to do is emp.email, for example, equal, let's say, Mohamad at yahoo, for example.com, for example. So here, for example, I was able to update my email directly from here, although I don't want it to be like that. And I was able, for example, to modify it, although I don't want to allow immutability in my initiated object. So how would I achieve immutability in my code prior to C# 9? So for example, one of the method that I can do is I can change this, for example, from set to private set. And let's take this. And then, for example, after this, what I can do is I can introduce a constructor. This is going to be employee. And here we're going to have 3 variables, going to be first name, last name, email, and then I do the assignment here. So last name equal name, and email equal email. Okay, great. So here we have employee, and we have first name, last name, and email. And we can see here we have put a private set, so no one can really set it up after the object has been initiated, and this will not work anymore. So let's comment this out, and let's create a new employee. So var emp equal new employee, and instead of initiating that way, I need to initiate it through constructor initiation. So it has to be something like this. So the first name needs to be Mohamad, and last name is going to be Lawand, and email is going to be Mohamad at email.com. So now I got the same output. Basically, I have initiated my object. Now let's see if I'm able to update my email address. So emp.email, let's say, equal to Mohamad at yahoo.com. And we can see here that the IDE, or the text editor, and the compiler are complaining, because we can see here from the error message that we cannot be used because the accessor is inaccessible, because we have set it as a private set. So that's a really good way to do it. But you can see here we have added a lot of code in order for us to do that. So another option that we got is, without having a private set, we could have deleted those and just have a getter. But this also is going to lead us to the same way. We have a lot of code. We had to add another constructor. And let's say we have added new properties. We need to make sure that we have added all of this information to the constructor. And basically, it's a bit more tougher for us to manage. So how can we do this within C# 9? So we're going to be creating a new class, also employee, but just so we can compare them. So let's create a new class. And we're going to call it employee. So we can just compare. It's going to be the same information, but so I just want to create 2 classes side by side so we can see the difference. So employee, and it's also going to have 3 properties. So it's going to be a string, first name. We're going to call it employee new, so the compiler will not complain. And then we're going to have another property, string, last name, and property string email. So now you think to yourself, okay, this is same as it was before. So let's revert it how it was before. Set. Let's put the semicolon here, and let's remove this. Let's comment out the constructor. We don't really need it. And let's comment this out. And let's, okay. So now we were back to square one, where we are basically having the old way of implementing things. So how can we within the same structure, make it immutable. Very simple. Within C# type, all we need to do is change the word set to init. What does this mean, the word init? So this words mean here that we can only set up this property only on the object initialization. So basically it has the same structure as this, so it's like a private set, but the only difference is only when we are initializing the object we are able to access it, and there is no way for us to do it in any other way. So here, for example, employee is initialized, and then here you can see it has been, we are able to update it. But if I create a new employee, for example, I say var emp2 equal new employee, new, bad name, but what can we do right now? It's only for the sample application. And here, for example, we'll put first name equal Donald Duck, for example, Donald, and last name is Duck, and the email is gonna be donald@email.com. And let's see right now, if I want to change the email, all I need to do, for example, emp2.email equal, I don't know, @.com. And as you can see, it's complaining because we are trying to update this object after it has been initialized, which shouldn't be the case. So this small change here of changing the set to an init made our code immutable of changes after initialization. And this is a really neat feature that will allow us directly to keep the code smaller, to keep it more maintainable, and it's much more easier to read than having a constructor and then trying to keep track of whatever the changes that happen here. We need to make them in the constructor and so on and so forth. So this is init-only setters, and basically the init-only setters will gonna give us immutability inside our code. The next feature that we're going to be discussing is default interface methods. When we think of interface in C#, we look at them as the blueprint of our code. They let us know the methods and the properties that we can use when we are working with different classes and struct methods. But now we have default interface methods which allow us to add like a default implementation to the new methods. We want to add existing interfaces. So let's create an interface and a class and see how all of this works together. So let's create a new interface, and this interface, we're gonna call it I do work. And this interface basically is gonna have right now one method. We're gonna call it, it's not gonna turn anything, and this method is gonna be called work hard. Great, so now we have a nice interface and we have a method inside this interface. Now let's say we have another class, and this class is gonna call it machine. And right now what we wanna do is we wanna implement this interface to this class. How do we do that? Or we have to add a colon and we put I do work. Great, and now this is gonna complain because we are utilizing this interface but we are not implementing the methods. So that's the first thing we need to do. So if we click here on it and we click on this implement interface, and we can see right now that the method has already been implemented. Now let's delete this. All we're gonna do, for example, here is console.writeLine, and we're gonna say I am working hard, for example. Great. So now we have implemented the interface and it's working as it should be. So let's go back to our application here and let us initialize this object. So how do we do that? It's very simple. So we said machine. We're going to be utilizing the target type new expressions in order for us to initiate this object. So machine equal to new, as you can see here. And then we're going to say machine dot work hard. It's very simple. Let's build our application. .NET build and .NET. Let's make sure that it's working. So .NET run. And as you can see here, we have I am working hard, which basically means that the class has correctly implemented the interface, and we have initiated this method and we are able to see the console. Great. So now what will happen if I want to add additional interfaces to my code? I want to add more feature and I want to add more methods to my interface, so I can do something like the following. So let's go back to our interface, and within this interface I want to add, for example, void مثلا take a break. So I want to add this type of this new method, and because I added the new method in the interface, all of the classes that are automatically utilizing this interface, I need to implement this method within those. But let's say I have this application running in production, and all of the code, or for example other features of my application are utilizing this interface, and I don't want to really break their implementation. I need to figure out a way where I can add all of the methods that I want without basically breaking all of the previous implementation. So I need to have some kind of a backwards compatibility in order to make sure that my interface has all of the latest features that I want, but also it does not break any previous implementation on any previous utilization of my interface and my method, etc. So how do I do that? The main solution for this, or the only solution for this, is going to be utilizing the default implementation for the interface. In this case, the method has not been implemented by any class, and what I need to do is I need to add some kind of default implementation for it. So in case that class that is utilizing this interface does not implement it, the default implementation will take place and will automatically use it from there. So how do I add this default implementation, you might ask? It's going to be very simple. So instead of having here a semicolon, all I need to do is make it as a function, and inside this brackets I can put add default implementation. And for example, what you can do is we can put for example console.writeLine. We can say this method is not yet implemented. And for example, you can add a not implementation accepted. So it's going to be throw new not implemented exception. So right now I have created a new method that I want, and we can see here that the class, or the I do work here, is not complaining anymore because I had added the default implementation, and it's automatically utilizing this default implementation of instead of me rewriting it. So let's say I want now to utilize this take a break functionality. How do I do that? It's going to be very simple. So what we can do is we can put public void take a break, and now we can see why is this complaining. And within this take a break here, I need to return like let's say a new console, and inside this console we can say I am taking a break. And let's go back to the application and let's initialize this function. So machine.takeAbreak, and now let's build and run. So .NET build, perfect, build successfully. .NET run, perfect. We can see the two results coming out. We can see the first one, which is I am working hard, and the second result, I am taking a break. Great. So this default implementation will allow us to save a lot of, to make sure that we have a lot of backward compatibility. We can make sure that the code we are running does not break anything else. So we can make sure that all of part of our application that utilizing this interface are still working as it should be. We're not breaking any of them. We are not damaging them. And as well, we are allowing the new implementation to have more functionality, more features, better handling, all of those by adding those default implementation. So the last feature that we're going to be discussing today is tuple pattern matching. We are going to discover what is tuple matching in the context of a switch expression. We will create a function of rock, paper, scissors, and we're going to express this function using tuples that we're going to build the switch on. We will utilize tuple literals to switch the code on, and based on the literal evaluation, we will express the result. So let us build this switch statement. So inside our code here, and this switch statement is gonna return a string, and we're gonna call it a simple rock, paper, scissors. Great. And we can put string player 1, string player 2, and then basically we're just gonna utilize an arrow function, and we're gonna pass player 1 and player 2, and based on that we're gonna do the switch, and this switch basically is gonna take what are the move that player 1 did and player 2 did in order for us to decide on the result. So let's add a semicolon at the end, and we're gonna be utilizing here the tuple literals to do the switch on. So we say, let's say player 1 do rock, and let's say player 2 does paper. The result is paper wins. Let's add, for example, rock and scissors. Rock will win. Rock wins. And then let's say if player 1 does paper and player 2 does scissors. Sorry, let's make it rock. We'll put paper win. Three more of these, so we'll have like a general case. Let's put if paper and scissors will win. Scissors wins. And let's say the last two is gonna make in scissors with paper. We're gonna make it scissors win. And lastly, we're gonna put scissors and rock. Scissors and rock. And basically rock will win. Rock wins. And finally, let's add the default. Because we are using tuples, we need to put 2. And then here it's a tie. So no one wins. Great. So let's explore what we have done here. So first of all, we have created what is the output of this switch expression. We have given it a name, and then we have described here the tuples. So basically, we said it's gonna take 2 inputs. It's gonna be player 1, and it's gonna take, sorry, these are the input of the function. So it's gonna say like it's gonna take player 1 and player 2, and here we have decided that this is gonna be the main switch expression, which is player 1 and player 2, which is gonna be the tuples. And here, based on the tuple literals, we are making the switch on. So these are called tuple literals, and based on these, the switch is happening. So let's see how we can utilize it. So let's put, for example, let's create a new variable. We'll call it result equal the rock, paper, scissors. Great. And let's say player 1 is gonna utilize the rock, and player 2 is gonna utilize the paper. And let's create a console dot write line. We're just gonna put the result, which is gonna be using string interpolation. Put the winner, for example, it's, and here we put result. And let's build our application. So .NET build. Great. Now let's run it. .NET run. And as we can see here, we have the winner is paper wins, which means that this method here, it automatically passed rock and paper, and then it automatically passed it here, rock and paper, and then within the switch statement, we are matching rock and paper, and we got the first one. So let's add another one, and let's switch it up a bit to see if it's actually working as it should be. So instead of rock, we're gonna put, for example, paper and scissors. And this is result 2, and let's output this. So it's gonna be result 2, and let's run this application again. So first let's build it, .NET build, and then now let's run it, .NET run. Perfect. Now we can see at the end that we have the winner is scissors, because based on that condition that we have here, scissors wins over paper. Perfect. So basically this summarizes the tuple pattern matching. This feature, we can see how we can utilize tuples, which is a really powerful thing in order for us to make a more powerful switch expression. So as a summary, today we have covered the targeted type, a new expression, property pattern matching, tuple pattern matching, init-only setters, and default interface methods. And all of these together will allow us to write more sustainable, maintainable, and testable code, and will allow our application to run much more smoother and much more easier for us to read and build on top. Thank you very much for watching this video. Please share and like if you like the content. As well, please comment in the comments down below any question or any inquiries that you might have, or if you have any ideas of a video that you would like me to cover, please add them all in the comments down below. Have a great day.